We'll start in 1 minute. Today we'll start the paper practice final exam. Reminder, the final exam is on Monday, November 30th, and it will be from 3 p.m. to 5:15 p.m. But it's on Newton. So I'll give you reminders of this until going into next week. But we'll have a Zoom proctor meeting for the final. So you'll enter the Zoom meeting and then take the final on Newton. There are there's a practice final exam on Newton that you can take up to 3 times. So I would advise that you take the Newton practice final exam at least once so that you're familiar with what to do when you take the real final exam on Newton. Okay, but we'll go over the paper sample final exam. So these instructions are similar to what you'll see. You'll have 2 hours plus 15 minutes. So when you're taking the Newton final exam, still you should show your work on paper and simplify answers. And then after you take the final exam, email your final exam papers to me. If you enter a problem incorrectly, of course, Newton won't give you partial credit. So that's why you need to send in your paperwork. And if you deserve partial credit, then you will be given partial credit on the work that you show on paper. Okay, here on this one, this says graph the horizontal line going through the ordered pair -2, 3, and then write the equation of that horizontal line. Okay, the point -2, 3 is right there, the horizontal line. That's the horizontal line. The equation for that horizontal line is y equals the y coordinate, 3. So every point on that horizontal line has the same y coordinate of 3. So that's why we write y equals 3. If you only write the number 3, that's not incorrect. It must be y equals 3. In the next problem, rationalize the denominator for the square root of 15 divided by the square root of 35. What I would suggest in this case, rewrite the square root of 15 and the square root of 35. The square root of 15 is the square root of 5 times the square root of 3. And the square root of 35 is the square root of 5 times the square root of 7. And then the square root of 5 divided by the square root of 5 is equal to 1. So we can focus on simplifying the square root of 3 over the square root of 7 and rationalize the denominator. So what we do is we multiply by 1 in the form square root of 7 over the square root of 7, because we want to get rid of the square root in the denominator. And we're multiplying by 1, so we're not changing the value. And so we'll just end up with the square root of 21 divided by 7. So that is the simplified answer for that one. The next problem, number 3, the discriminant for the quadratic equation 2x squared minus 5x minus 7 equals 0 is 81. So hopefully we know automatically how to classify the solutions. This one is multiple choice. The first choice, no solutions. The second choice, part B, 2 distinct real solutions. Part C, 1 real solution. Part D, 2 distinct non-real complex solutions. And part E, infinitely many solutions. 2 of those options are never true for a quadratic equation. A quadratic equation always has solutions. So rule out part A. The most number of solutions is 2, so there can't be infinitely many. And if you still don't know, well, just solve the equation and then using the quadratic formula, and then you'll know how to answer it. But remember, the discriminant is b to the second minus 4ac. That's the number that's inside the square root. And if that number is positive, it means there are 2 distinct real solutions. So part B is the correct choice. 2 distinct or 2 different real solutions. Okay, number 4, use the AC method to factor 6x squared plus 5x minus 14. Okay, notice this is not an equation, this is just a quadratic expression. So we're not solving an equation here, we're just factoring a polynomial. So that is an important difference. We're not solving an equation, we're just factoring it. Okay, use the AC method. Well, if the instructions on the final say use the AC method, then you'll want to show that work on paper. So in the event that you type in an incorrect answer, you might be able to get partial credit back. So we multiply 6 times negative 14, and that is negative 84. So we want to see if we can find 2 integers that have a product of negative 84 and a sum of positive 5. Okay, so we'll pick pairs of integers that have a product of negative 84, but we'll pick them in such a way that the one with the largest absolute value is positive. Since they have to add up to a positive, the one with the largest absolute value is positive. So in our systematic approach, we would start negative 1 times 84. Then negative 2 times 42, those add up to 40. Negative 3 times 28. Negative 4 times 21. We're getting closer. Negative 5 is not a solution. Negative 6 times 14. Those add up to 8. And then negative 7 times 12. Negative 7 and 12 have a sum of 5. So negative 7 and 12 are the 2 integers. This guarantees that we can factor it. So we replace the middle term plus 5x with minus 7x plus 12x. And then we factor by grouping. Out of the first two terms, we can factor out x, that's the greatest common factor, x times the quantity 6x minus 7. The middle operator is addition, so we bring down the middle operator. And then the third and fourth terms, the greatest common factor is 2. And the binomial is 6x minus 7. So these binomials have to match 6x minus 7. So the last step, 6x minus 7 times x plus 2. So you should show this much work for this particular kind of problem. On number 5, find the restricted values of the rational expression. Well, to find the restricted values, we only need to focus on the denominator. So in general, we say denominators cannot be 0, so we can write x squared plus 2x minus 8. That can't be 0. And then we solve this inequality by factoring, the same way we would solve an equation by factoring. So the left-hand side factors pretty nicely, x plus 4 and x minus 2. So if a product of two numbers is not 0, then neither of the numbers is 0. So x plus 4 is not 0, and x minus 2 is not 0. So x cannot be negative 4, and x cannot equal positive 2. Okay, but if you just answer the question directly, the restricted values are negative 4 and 2. So the term restricted implies that x cannot be negative 4 and 2. So if you want to put in a little bit more detail, the restricted values for x, since x is the variable, are negative 4 and 2. Okay, let's move on to the next page. Yeah, this one, a word problem. It says Kevin has a collection of 41 coins consisting of nickels and quarters. The total value of the coins is $4.85. Let n be the number of nickels and q be the number of quarters. Set up but do not solve a system of equations that can be used to determine the number of nickels and quarters in the collection. Okay, so one of the equations has to do with the number of coins. And the second equation has to do with the value, the monetary value of those coins. So if n represents the number of nickels and q represents the number of quarters, and altogether there are 41 nickels and quarters, then one equation is just the number of nickels n plus the number of quarters q equals 41. Each of those n nickels is worth 5/100ths of a dollar. 5 pennies, 5 cents. But in terms of dollars, it's $0.05 for one nickel. So the value of n nickels is represented by 0.05 times n. the value of each quarter is 25 hundredths of a dollar. So we write the value for Q quarters is 0.25 times Q. And we're told in the problem itself what the value of those 41 coins is, $4.85. So 4.85. Okay, in this problem, this is all you would have to do. Just write down the two equations. Okay, number 7, find the slope and the x and y intercepts of the line 2x plus 5y equals 11. And then write the intercepts as ordered pairs. Let's find the y-intercept first. So what do we know about every y-intercept? Besides graphically, it means that that's the place on the y-axis that the line crosses. But what else does it mean?
Is it every x-intercept is equal to 0?
The x-coordinate of the y-intercept is 0. Yeah. So to find the y-intercept, we replace x with 0. So in this equation, when x is 0, we get 2 times 0 plus 5y equals 11, or 5y equals 11, or y equals 11 fifths. Okay, so the y-intercept as an ordered pair, so the y-intercept is the ordered pair 0 for x and 11 fifths for y. It's an ordered pair. So if you just type in or answer 11 fifths, that's not correct, because the y-intercept is a point in the xy plane, and every point in the xy plane is associated with an ordered pair. Okay, to find the x-intercept, what's true about every x-intercept? Well, if a line crosses the x-axis at a point, that point is the x-intercept. But what's true about every x-intercept besides the fact that it's the place on the x-axis that the line crosses?
It has the y-coordinate that's equal to 0.
The y-coordinate is equal to 0. Yeah, so every x-intercept has a y-coordinate equal to 0. So when y equals 0, in the equation, replace y with 0, and we're left with 2x equals 11, or x equals 11 halves. And so the x-intercept is the ordered pair 11 halves for x and 0 for y. So what else are we supposed to find? We're supposed to find the slope. Find the slope of that line. Well, there's more than one way to do it. One way is just to rewrite the equation so that it's in the y equals mx plus b form. That's called the slope-intercept form. Y equals mx plus b, the number m is the slope. That's one way to do it. Another way is to use the two ordered pairs and the slope formula. Right, we know what the ordered pairs of two different points on the line are, so we can use the slope formula. So let's do it both ways. Let's rewrite the equation so that it's in the form y equals mx plus b. You need to know both of these things, so let's do both. You also need to know the slope formula. So solve the equation 2x plus 5y equals 11 for y. So I'll rewrite 2x plus 5y equals 11. Then subtract 2x from both sides. We get 5y equals negative 2x plus 11. Then divide every term on both sides by 5. We get y equals negative 2/5 x plus 11/5. So the slope is m equals negative 2/5, the coefficient of x, when it's in the form y equals mx plus b. And incidentally, note that 11/5 is the y-coordinate of the y-intercept, which is why they call this the slope-intercept form. Okay, the slope formula, m equals y2 minus y1 over x2 minus x1. So if we use those ordered pairs, so I'll pick 11/5 for my y2. So 11/5 minus 0. That's my y2 minus y1. And then my x2 minus x1 will be 0 minus 11/2. So we get 11/5 divided by negative 11/2. So I sort of run out of room here. Up here, I'll continue what we're doing. So 11/5 divided by negative 11/2 is equivalent to 11/5 multiplied by the reciprocal of negative 11/2, which is negative 2/11. And then 11/5 times negative 2/11. The 11s cancel each other out, and we're just left with negative 2/5 for the slope. Yeah, that's the same number we got using the other method. Okay, number 8, find the distance between the points -4, -1, and -5, 2. And here it says round your answer to the nearest tenth. Okay, if I've been putting you to sleep, now I'll wake you up by saying that I'll wait for a minute or so, and you can type in the answer rounded to the nearest tenth. So what did you come up with if you're on YouTube? All right, let's go ahead and do it then. So I'll pick -4 minus -5 quantity squared for my x2 minus x1 quantity squared, and then plus -1 minus 2 quantity squared. All of that's inside the square root. So -4 minus -5, that's the same as -4 plus 5, which is 1 squared. -1 minus 2 is -3, so plus -3 squared. So -3 squared is 9, 1 plus 9 is 10, and so the square root of 10. So it's 3 point something. Yeah, use your calculator and then round it to 1 decimal place if you want. Well, if it's the test problem, that's what you have to do. Okay, let's move on to the next problem. Solve the equation 5 plus the absolute value of x minus 9 equals 11. Wow, that's a major hint. Give both solutions for x. So it's implying that there are 2 solutions. Okay, answer that. Type those answers in. This will be not too hard. You don't have to round it to a decimal place. So I take it your fingers are too hard or too tired. They can't type in an answer. There's an answer, 15 and 3. Well, we can check those. If x is 15, 15 minus 9 is 6. The absolute value of 6 is 6. 5 plus 6 is 11. Yeah, so 15 works. Now check 3. 3 minus 9 is -6, but the absolute value of -6 is 6. 5 plus 6 is 11. That's also true. Yeah, so 15 and 3 are the solutions. We should go through the process. When solving an absolute value equation, we want to isolate the absolute value first. So the first step is to subtract 5 from both sides. So we get the absolute value of x minus 9 equals 6. And then if the absolute value of a number is 6, then that number could be +6 or it could be -6 if its absolute value is 6. So when we remove the absolute value symbols, we get 2 equations. One is x minus 9 equals 6. The other is x minus 9 equals -6. And then solve each of those for x. If x minus 9 is 6, add 9 to both sides, we get x equals 15. If x minus 9 is negative 6, add 9 and we get x equals positive 3. Okay, the next problem, Mildred can row about 3 miles per hour in still water. On a river, it takes her the same time to row 14 miles downstream as it does to row 7 miles upstream. Let x be the speed of the current. Give an equation that represents this problem, but do not solve it. Okay, so eventually we want to get a single equation whose only variable is x. But before we get to that single equation, we're going to need, 2 or 3 equations in the setup. Okay, so let's reread this. Mildred can row about 3 miles per hour in still water. So Mildred is like a machine. She just always rows at 3 miles per hour. On a river, it takes her the same time to row 14 miles downstream as it does to row 7 miles upstream. And we're going to let x be the speed of the current. So the first thing we'll do is we'll set up an equation representing the trip downstream, and then another equation for the trip upstream. So this is a uniform motion problem, so equations are related to rate times time equals distance. Hey, when Mildred is rowing the boat going downstream, that's with the current, the boat will be traveling at 3 plus x miles per hour. And in a certain amount of time, I'll call it t hours, she will have traveled a total distance of 14 miles downstream. Okay, when she's going upstream or against the current, the boat is only traveling at 3 minus x miles per hour. How should I represent time for this equation? Well, here's the clue on that one. It takes her the same amount of time to row 14 miles downstream as it does to row 7 miles upstream. So if it takes her t hours to row 14 miles downstream, the same t hours is taken to row 7 miles upstream. So in this problem, the two values of t are exactly the same. They're the same amount of time. So we note t from one equation is equal to t from the other equation. That's given in the problem itself. Okay, so that helps us. We're just a couple of steps away from getting an equation whose only variable is x. So the top equation, 3 plus x times t equals 14. If we solve that for t, time is equal to distance divided by rate. So t is equal to 14 divided by 3 plus x. But then we do the same thing for the second equation. 3 minus x times t equals 7, solve for t. Time is equal to distance divided by rate. Okay, but since the two amounts of time are the same, it must be the case that 14 divided by 3 plus x is equal to 7 divided by 3 minus x. So in this problem, if you're not going to solve it, then that is the answer. Its only variable is x. Hey, let's move on to the next page. Yeah, the directions say, or ask, how many ordered pairs solve the system? So in this one, the system itself is given, as well as the graph of the two lines in that system. But either way, we should be able to determine what the number of ordered pair solutions are. Well, the two lines have the same slope. Graphically, well, they have the same slope but different y-intercepts. So graphically, it means the lines are parallel and they do not intersect. So parallel lines do not intersect. That means the system has no solution. So you can easily find the slope of each of the lines. The slopes are the same. But another important point is that the y-intercepts are different. The two lines do not intersect. Okay, so no solution. If you're typing in an answer in Newton, they will probably want you to type in 0. How many ordered pairs solve the system? 0 solutions. Okay, then another question, is the system consistent or inconsistent? Well, it's inconsistent because if you try to solve the equation, you'll end up with nonsense. So this is inconsistent. So attempting to solve it leads to a nonsensical result. So inconsistent is the word that goes with that. Is the system dependent or independent? Well, dependent means the two lines are the same line, but these lines are not. So this is independent. The two lines are independent. Okay, moving on. Solve the equation x minus 2 quantity squared equals 11. Well, there's more than one way to go about it. The easiest thing to do is what? Well, in my opinion, the easiest thing to do is to apply the square root property, because we have a binomial squared equals 11. So apply the square root property. That's the easiest thing to do, in my opinion. So applying the square root property, we get x minus 2 equals positive and negative square root of 11. So x equals 2 plus and minus the square root of 11. A more time-consuming way, I won't go through the whole thing this way, but if you square the binomial x minus 2, x squared minus 4x plus 4 equals 11, get the equation in standard form by subtracting 11, x squared minus 4x minus 7, and then using the quadratic formula, you'll still get the same results. But as you can see, that approach will take more time than just applying the square root property. Okay, the next problem, solve the equation x plus 6 times x minus 5 times 3x minus 2 equals 0. So how would you go about starting this? You can type in an answer, a really short answer. The first thing, what's the first thing you're going to do when solving this equation?
Start multiplying the binomial.
You're gonna multiply it out? Is that what you're saying? Okay. Yeah, I got an answer in the classroom. Multiply the binomials. Is there anyone that has a different approach? Okay, well, my advice, my strong advice, is to not multiply the factors. So if you think, oftentimes we solve equations by factoring. In the previous example, we didn't solve that equation by factoring because it was all set up to apply the square root property. But if you have an equation and one side is already 0 and the other side is already factored, all of the work, almost all of the work has been done for you. So if we continue the process of solving by factoring, right? If we multiplied those out, we would then have to factor it, but it's already factored. So what we do is we set each factor equal to 0, and then solve each of those equations. So underlying this this procedure is the zero product property. So if you multiply two numbers and the product is 0, then one or the other of the numbers has to be 0. So here we're just multiplying three numbers and the product is 0. So the possibilities, one of the numbers could be -6 or it could be +5. On this one, add 2 and divide by 3, x equals 2/3. So those are the three solutions. Those are the three numbers that give you a product of 0. They simplify the square root of 54y to the 6th. Since it's a square root, we want to find the largest factor of 54 that's a perfect square. 9 is a perfect square. 9 times 6 is 54. Y to the 6th is a perfect square because the exponent 6 is even. So we can rewrite this as the square root of 9y to the 6th times the square root of 6. And then we simplify the square root of 9y to the 6th to 3y to the 3rd. So our simplified answer is 3 times y to the third times the square root of 6. Okay, the next problem, solve the formula P equals 2L plus 2W for L. So the first thing to do, well, you can go about it in a couple of different ways. But what I would do is I would first subtract 2W from both sides. So P minus 2W equals 2L. And then divide every term on both sides by 2. So remember to divide everything, the entire quantity P minus 2W by 2. 2L divided by 2 is L. A correct answer can be in a different form, but this is, you don't need to get fancy, just leave it like that. Okay, the next problem, evaluate, if possible, showing work. 125 to the negative 2/3. So if you have a negative exponent, 125 to the negative 2/3, that's equivalent to 1 over 125 to the positive 2/3. When you have an exponent that is a fraction, the denominator of the fraction in the exponent is the root that you want to compute of that number. So if you remember that in this class, things almost always work out really nicely. So think of 125 to the 2/3 using properties of exponents as 125 to the 1/3 all raised to the exponent 2. One of our properties of exponents, if you have a number raised to an exponent, and if that is raised to another exponent, you can multiply those exponents. 2 times 1/3 is 2/3. But writing it this way perhaps helps us see that 125 to the 1/3 simplifies to 5. Right, the third root of 125 is 5 because 5 to the third is 125. So in the next step, we write 1 over 5 to the second. So in other words, 125 to the 1/3 simplifies to 5. And then finally, 1 over 5 to the second is 1 over 25. So another thing, just to remind you, the negative exponent has nothing to do with the sign of the number. This number is positive, it's not negative. It's possible to have numbers with negative exponents that do simplify to negative numbers, but the negative exponent isn't what makes a number negative. Okay, let's start the next page. Okay, number 17. Change 7x to the third to the exponent 2/5 into an equivalent expression in radical notation. So here's a reminder. If you have some expression A with a fraction in the exponent, like m over n, the denominator of the exponent is the same number as the index of the radical. So this number n is the denominator. That's the nth root. And then a to the m goes inside the radical. Okay, so another way to view a to the m over n is a to the m over n is a to the m to the 1 over n. And anything raised to the 1 over n can be written as the nth root of a to the m in radical form. Okay, so we're just down to a few seconds. In this one, 7x to the third to the 2/5. So the radical has an index of 5. And on this one, we can write 7x to the third in parentheses to the second. It's not correct without parentheses. If you don't want parentheses, you don't have to write parentheses, but 7x to the third to the second is 49x to the 6th. Okay, we're out of time. On Monday, we'll continue with this final exam practice. We'll also have class on Tuesday of next week. And if we get through the practice final exam on Monday, I'll find some other material to go over on Tuesday of next week. But that is all for today.